Okay, today we're going to talk about multiplying algebraic fractions. Please make sure that you take out a sheet of loose leaf paper if you chose not to print out these notes. When we're multiplying an algebraic fraction, what we're going to do is first factor all the numerators, the tops, then we're going to factor all the denominators, the bottoms, then we're going to reduce anything anywhere on the top with anything anywhere on the bottom. Once we've reduced, we're going to multiply across. And then again, like the other day, key point, if the factors are reversed with a minus, they reduce to a -1. So if we look at the example, if you have x minus 2 and 2 minus x, they reduce to a -1. So if we look at the first example, it's a lot of factoring. The first numerator, I notice that there is an x in both terms. So I'm going to take out a greatest common factor. The first denominator does not factor, so I'm just going to rewrite it. The second numerator, you might want to put a 1 here. We're looking for numbers that add to -1 and multiply to -2. So if you list your factors off to the side of -2, the only choice you have are 1 and 2. If I make 2 minus 1 gives me positive 1, so I'm going to switch the signs. So this factors to x minus 2, x plus 1, and the second denominator, reduces or factors to x plus 1, x minus 1. You might want to put a little star here because, again, that is the difference of two perfect squares because one is a perfect square. Now I'm going to look. Anything anywhere on the top will reduce anything anywhere on the bottom. So I have an x plus 1 and an x plus 1. I've also got an x minus 1 and an x minus 1. Here, I've got an x, and there I have an x. Now, if I look and multiply across the top, 1 times x minus 2 times 1 is x minus 2. If I look at the bottom, I have 3 times 1 times 1 times 1, so that's just 3. So this is my final answer. If I look at number 2, it says to multiply. So the first thing I'm going to do is factor all the tops and bottoms. For the first top numerator, I'm looking for numbers that add to 5 and multiply to 4. So that becomes x plus 4 and x plus 1. Again, if you need a review, we're going to write the factors of 4. We have 1 and 4 or 2 and 2. We want them to add to 5, so we pick the 1 and the 4. The first denominator, I notice they both have a 7, so I'm going to take out a greatest common factor. The second numerator does not factor, so I'm just going to rewrite 28. And the second denominator is the difference of two perfect squares, so I'm going to factor it as x plus 4, x minus 4. Now I'm going to reduce. I have an x plus 1 and an x plus 1. I've got an x plus 4 and an x plus 4. I've got a 7 here and a 28. So if I reduce that, 7 goes into 28 4 times. Now I'm going to multiply across the top. 1 times 1 times 4 is 4. 1 times 1 times 1 times x minus 4 is x minus 4. That is my answer. If I look at this one, again, since it says to multiply, the first thing I'm thinking of is factor everything. So if I factor the first numerator, both of these terms are perfect squares. So that becomes c plus 3, c minus 3. The first denominator, I'm looking for numbers that add to -1 and multiply to -20. So off to the side, if I list my factors of 20, 1 and 20, 2 and 10, 4 and 5, one of them has to be negative. This would give me +1, so I'm going to switch the signs. So I have c plus 4 and c minus 5. If I look at the second numerator, I notice that 4c goes into both. And if I look at the second denominator, I also know that 4c goes into both. So it's greatest common factor. Once everything is factored, now I get to reduce. Anything from the top will reduce or cancel anything from the bottom. So I have a c minus 5. I've got a c minus 3. Now, if I multiply across the top, c plus 3 times 1 is c plus 3. And on the bottom, c plus 4 times 1 times 1 times 1 is c plus 4. Please note, I cannot reduce the two c's in my answer because they are connected with the numbers with a plus sign. And the last example, the first one, when we go to factor, because there's a number in front of the squared term, that's when we do our headphone method. So here I'm looking for factors of negative 12 that add to negative 1. So that would be 1 and 12, 2 and 6, 3 and 4. One of them has to be negative. This gives me positive 1, so I'm going to switch the signs. Now, because it's got a leading coefficient, that is the factoring where we expand the middle term. So I'm going to write 2c squared. Then I'm going to take this 1c, and I'm going to write it as plus 3c minus 4c from these factors here, minus 6. Cut it down the middle. On the left, the greatest common factor is c. I'm left with 2c plus 3. I want 2c plus 3 on the right. I took out a negative 2. So my factors for that first numerator are c minus 2, the fronts, and then the repeated term. Now, if I go back and factor this bottom here, both of those terms have a 4 in it, so it's a greatest common factor. I cannot do anything with the 12. And the 6c plus 9, 3 goes into both of those. And I factored that. Now it comes to reducing. C minus 2, C minus 2. So those reduce to 1s. 2c plus 3, 2c plus 3. And if I look here, divide by 3, and if I divide the 12 by 3, I get 4. However, if I look now, I have a 4 here and a 4 here. So this entire problem reduces to 1 because everything canceled out. 1 times 1 times 1 on the top and 1 times 1 times 1 times 1 on the bottom. Please make sure you write down any questions that you might have and either email me or ask me next time you see me.